Okay, let's conclude our look at the proof of the safety of Gauss's method with the third and last case. We want to prove that if a linear system is changed to another by 3, replacing one equation with a sum of itself and a multiple of another, the two systems have the same solution sets. Okay, we're going to look at that now. And our goal is to show that a solution of a linear system also solves the linear system produced by the row operation and vice versa. Using the same notation as the first case, when we did the row swap, observe that the solution S solves the original system of M equations exactly when the following conjunction or logical AND of equations is true. We have S solves the first equation, S solves the ith equation, S solves the jth equation, and S solves the mth equation. Okay, in particular, because of this, because we can extract from a logical AND that they're all true. So if S solves EI and EJ, then we want to show that it solves EI and the transform J, E prime J. Now E prime J, well, this is basically the left-hand side of E prime J is K times the linear combination in EI plus the linear combination in EJ, and the right-hand side should be K times the constant in I plus the constant in J. Well, we want to show this is true. So what we can do is, we know that K is, K multiplies the linear combination EI. Well, we know that that linear combination equals DI, so we can, because we're assuming that S solves EI, so we can replace that with DI, and we're assuming that EJ is true. So the linear combination on the right, starting AJ1 up to AJN, that linear combination is equal to DJ. So we can substitute that value in, and that produces the right-hand side. So this is just the result, the equation that results from adding K times the ith equation to the jth equation. Now, we can turn this around and say, or check, that if S solves EIS and the transformed equation, which is K times EI plus EJ and given by the following form, then S also solves the original equation. So we know it already solves EI because we've assumed that. And we can get EJ because we can subtract K times EI from the equation just above. And on the left, that's going to subtract K times that linear combination and will be left, and on the right, it'll subtract K times DI, so be left just with the original EJS. This means that the logical condition that S solves the original system is logically equivalent to the condition that S solves the transform system, the one with the row replacement. If we want to see how this works with sets, we can do the same, display the same set definitions we had before in the original definition with E1, EI, and EJ up to EM, and then replace that with the transformed version apart from the typo of the raised parentheses in the EI. And this will be logically, these two expressions, logical expressions are logically equivalent as they have the same truth values. So they're going to determine the same set of the same elements. So the S original is equal to S with the row replaced by the combination. The proof patterns used in this are essentially the same as those in 2. And we've proved all 3. So therefore, we know that Gauss's method is safe.